right, today we are going to be continuing our discussion of all the different angles that are formed by the coordinate plane. And instead of just sketching them and finding coterminals, today we're actually going to be evaluating the trig functions of any given angle. So we've done the trig functions for acute angles that are in given right triangles. Now we're going to extend that to any given angle that we could draw in the coordinate plane. So, two learning goals for today. First, we need to be able to find what's called a reference angle of any given angle. Then, once we have found that, we're going to be able to calculate the 6 trig functions. So not just sine, cosine, tangent. Remember, we now know 6 trig functions. So, what I want to point out here is a general definition of trig functions when we're talking about the coordinate plane. If I am talking about this angle right here, every angle can form a triangle, either itself or the angle that would complete the x-axis. So here, this angle that I am marking theta would complete the path toward hitting the x-axis here. And this is what we would call the reference angle, and we'll get to a more standard definition here in a minute. But this theta would be the reference angle for this angle that I have sketched with the arrow, because it is what completes the angle with the x-axis. When we are looking at a triangle that we have drawn from an angle, this side right here, which I should probably color code these, it might make it easier. This blue side right here, that's on the x-axis. So we're going to call that x because it's going to come from an x coordinate. This side would go up in your y values, so we're going to call that side y. And then, because this side is formed from the radius of a rotating circle, we're going to call this side r. So if we're referring to those sides of the right triangle formed by angle theta, and we call them x, y, and r, then once I have it labeled that way, most of you, I'm sure, could very easily find my sine of theta, my cosine of theta, my tangent of theta, and then hopefully you've been studying and know the pairs that go together, cosecant of theta, secant of theta, and cotangent of theta. So sine of theta, here's my theta. Sine is opposite over hypotenuse. So the opposite side from theta is across, which is the y. The hypotenuse is r. So y over r. Cosine would be x over r because it's adjacent over hypotenuse. Tangent, opposite is y, adjacent is the x. So y over x. Now, cosecant, secant, and cotangent should be very easy now because hopefully we know that we just have to reciprocal them. So this one, r over y, r over x, and cotangent would be x over y. Now, let me just show you how this relates. This right here, I could pick out as a single point on that terminal side. That point, we can call its ordered pair the general x, y. Notice that the x coordinate is exactly the length of x here, because distances aren't negative, remember. And the y value would be its y coordinate. So we didn't just pick x and y out of the hat, they came from somewhere. They came from the fact that if we drew the triangle from that point, that those are the coordinates, and therefore these would be the actual lengths. So if we were at the point negative 2, 3, x would be 2, again, because distance wouldn't be negative, and y would be 3. Okay, so now let's talk about evaluating trig functions because it does get a little messy when we're talking about quadrants that are not quadrant 1 because not all of our trig functions are always positive. We have a way for remembering which trig functions are positive in which quadrants, and it looks a little like this. ASTC. Going from quadrant 1 to quadrant 4, so counterclockwise. A stands for all, S stands for scholars, T stands for take, and C stands for calculus. So all scholars take calculus is how you are going to remember this, and you do need to remember this because this is going to hint to you which trig functions are positive in that quadrant. So I'm going to write that out real quick. So it tells us which trig functions are positive in that quadrant. So quadrant 1 has the A. So the A stands for all. All of the trig functions are positive in quadrant 1, which is why you've never had a negative value before because we've always been working in acute angles. So now when we move to quadrant 2, S stands for sine. So sine is going to be positive in quadrant 2. Now, if sine is positive, its reciprocal would also be positive. So we can add a little and cosecant because they go together. So sine is positive, cosecant is positive, but all the other ones will have a negative value. In quadrant 3, our T means the tangent is positive in that quadrant, which means cotangent will also be positive. And finally, in quadrant 4, cosine is going to have a positive value, which means secant will as well. All right, last thing we need to understand, and I briefly mentioned it before, if theta is an angle in standard position, its reference angle, and this is huge because everything we're going to do in the unit circle is based upon being able to find a reference angle. A reference angle is always an acute angle, and we'll call it theta prime, formed by the terminal side of theta and the x-axis. So, I'm just going to give you an example here. Let's say that this is my angle theta. And let's say that that's, 210 degrees or something like that. This is my theta. If my theta is 210 degrees, my reference angle, my theta prime, is the acute angle formed by the terminal side of theta. So here's my terminal side. So draw it a different color. And the x-axis. Here's the x-axis. So the angle formed by those two would be right here. So here would be my reference angle. If I had an angle that went right here, if this is my theta, the angle formed by this terminal side and the x-axis would be right here in blue. This would be my theta prime. So it's always the x-axis. Always, always, always. So when you have a reference angle, it's the terminal side and the x-axis is how it's formed. All right, that's going to be important as we do our examples. So example 1, use the given point on a terminal side of angle theta in standard position. Evaluate the 6 trig functions of theta. So first thing I need to do is plot it. So -4, -3. 1, 2, 3, 4. 1, 2, 3. So here's -4, -3. And it says on the terminal side. So that means the terminal side of my angle theta goes right through that point. So connect it to the x-axis. Here is theta. I should know my x value and my y value. So here, it's a length of 4, 3, and then you're going to have to figure out the third side, the hypotenuse. So many of you probably just know what that is already, just from noticing patterns in geometry. But if you don't, Pythagorean theorem, 3 squared plus 4 squared equals r squared. So 9 plus 16 is r squared. So if r squared is 25, that means this side is going to be 5. So once you have them, then you set up your sine, your cosine, your tangent, and then cosecant, secant, and cotangent. So I've got all 3 sides, which means I should be able to find the trig values. So sine, opposite, over hypotenuse, 3 over 5. Cosine, adjacent, which is 4, over hypotenuse, which is 5. Tangent, opposite, which is 3, over adjacent, which is 4. Cosecant, reciprocal the sine, so 5 over 3. Secant would be 5 over 4, and cotangent 4 over 3. Now you are not done yet, because after you find those, you have to go to your All Scholars Take Calculus. This triangle is in quadrant 3, and in quadrant 3, tangent and cotangent are the positive ones, which means sine, cosine, cosecant, and secant are all negative. So tangent, cotangent, positive. The other ones should be negative. And that is our answer. Because it's quadrant 3, tangent and cotangent are positive. All right, let's try another one here. So negative 512 So left 5, up 12. Here's my negative 512. It's hard for me to connect, so excuse what's probably going to be a squiggly line. There we go. Remember, we always connect to the x-axis. So there we go. Here is my theta. I know that this is 5. I know that this is 12. Again, if you know what the third side is, that's great. It's a common Pythagorean triple. If you don't, you're going to do the Pythagorean theorem in order to come up with it. So 5 squared plus 12 squared equals r squared. So 25 plus 144 equals r squared. That's 169. So square root of 169 is 13. So it's a 5, 12, 13 Pythagorean triple. Okay, so now, once I have that, sine, cosine, tangent, cosecant, secant, cotangent. Let's fill them in. Sine, opposite, 12, hypotenuse, 13. Cosine, adjacent, 5, hypotenuse, 13. Tangent, opposite, 12, adjacent, 5. Cosecant, reciprocal this, 13/12. Secant, reciprocal of cosine, so 13 over 5. And cotangent, reciprocal of tangent. So now we've got our number values. Last thing we do is our All Scholars Take Calculus. So this is quadrant 2, which means S, sine, and cosecant are positive. So sine, cosecant positive, the rest of them are negative. And now I am done. All right, example 2, much shorter than the example 1s. Example 1s take much longer. Example 2, all it's asking us to do is sketch the angle, which we already did in 13.2a, so you should know how to sketch the angle. Then it's asking you to find its reference angle. So we need the sketch first. Once we find the sketch, we just have to find the terminal side and the x-axis. That will be our reference angle. So example 2a, 390 degrees. So if I'm sketching 390 degrees in the positive direction, that means I'm going counterclockwise. Here's 360. 390 is 30 more than 360. So there's my sketch of the 390. Then it says find its reference angle. Its reference angle is the angle formed by the terminal side and the x-axis. This reference angle is 30 degrees because we went 30 degrees over the 360. So 30 degrees is its reference angle. B, negative 250 degrees. All right, so if I'm moving in the negative direction, I know that this is negative 90, negative 180. The next quadrant would be negative 270, so it's 20 degrees short of that. So here's my negative 250. If I want my reference angle, again, terminal side and the x-axis, so don't tell me 20 because it's 20 degrees short of this. But how much over 180 is it? Because here's the reference angle. How many degrees did we go past the 180 is the question. So if this was 20, the whole quadrant is 90, that means that this is 70 degrees. So 70 degrees is my reference angle because you go 70 degrees past the negative 180. When you list a reference angle, it's always acute, remember. So we list it as that's a 70-degree angle, even though it's in quadrant 2. All right, I would like for you to try C here, just to kind of check your progress. So do this, pause it, and then come back. All right, so negative 120. If I go to here, that's negative 90. 120 is 30 more, so I need to go 30 more degrees in this direction to get my sketch. Notice that it's less than halfway, because halfway would be 45 degrees more, and I only needed 30. So negative 120, here is my sketch. My reference angle is the x-axis and the terminal side. So this in blue is my reference angle. If this little tiny part was 30 degrees, again, the whole quadrant is 90, so that means this reference angle is 60 degrees. So hopefully you came up with the correct answer. Now let's add a degree of difficulty and let's do this in radians because you have to be able to do both. So if you've got degrees, then let's check the radians. Theta is 2 pi over 3. Well, that's 2/3 pi. So 2/3 pi, if you converted it to degrees, pi over 3 is 60 degrees. So that's 120 degrees. But if you just, and I'm going to do this really lightly, if you divided your pi into thirds, because this line is the pi, so here's 3 equal pieces, 2 pi over 3 is to here. So 2 different ways you can reason through that sketch. Here's my sketch. My reference angle is going to be the x-axis and that terminal side. So here's my reference angle. Now, my original angle is in radians, so you need to write your answer in radians. This entire thing would be 3 pi over 3 because that's 1 whole pi. So if this is 2/3, that means all that's left here is 1/3 pi. So 1/3 pi is pi over 3. So my reference angle is pi over 3. You're thinking about what's going to complete the puzzle. If you've already used 2/3, there's only 1/3 left. All right, let's try another one of those. 5 pi over 4. Well, 5 pi over 4 is bigger than 1. That's 1 and 1/4 pi. So if I'm sketching it, here's 1 pi. I need to go another fourth. Fourth is a half of a half. So right here, exactly halfway between this quadrantal line and this one. So that's 5/4 pi. My reference angle here, terminal side, and the x-axis. So how much past 1 did we go? How much past 1 pi? Because that's my reference angle. Well, I went 1/4 past pi. 1/4 pi is pi over 4. So pi over 4 is my reference angle. All right, last one. Again, I'd like for you to try one that's in radians. So do this quickly. Pause it and then come back to check. All right, 11 pi over 6. 6 goes into 11 one time with 5 left over. This is 1 5/6 pi. So here's 1 pi. 3/6 would be to here. So 5/6 is almost all the way around. So 1 5/6 pi goes right to here. So when I'm finding my reference angle, x-axis, terminal side, it's right here. Again, this was 1 5/6. So I have used 5/6 of a whole. If I've used 5/6, how many sixths are left here? Hopefully you can tell me 1, because there should be 6/6 in one whole, and I've used 5 of them with the green part. So that means what's left is 1/6, which is pi over 6. And that is my reference angle. This has been your homegirl, Mrs. Thomas, coming at you live with the math for today. Catch y'all later.